Hello guys, my name is Yusuf Birbin. I'm from Palen Institute of Technology Information System. Today, I will explain my big data practicum. So in this practicum, we are going to do something really good. We are going to build a Python program that can automatically collect data from a website that has more than 10 pages of content all by itself without having to click anything manually. Pretty awesome, right? So let's get started. Okay, so first let me show you the website we are going to work with today. This website is called book.scrap.com, and this is actually a demo website that was built specifically for practicing web scraping. So it's completely safe and legal to use for learning purpose. No worries there. Now, if you look at this website, you can see it shows a list of books with their titles, price, ratings, and availability status. And if you scroll down to the bottom, you can see there's a next button here, which means this website has multiple page. In fact, it has exactly exactly like 50 page total with 20 books on each page. So our goal today is to build a program that can go top all 15 pages automatically and collect all 1,000 books into one single CSV file. Let's do it. All right, I will explain the Jupyter code. Let's jump into Jupyter Notebook. This is where our magic happens. So the very first thing we need to do in any Python project is import our libraries. Think of libraries like toolboxes. Each one has specific tools inside that help us do certain jobs. The first library we import request. This library is basically our internet connection tool. It lets our program send a request a website and receive the content back, just like when your browser loads a web page. But now our Python program is doing it instead. Next, we are import beautiful soap from the BS4 package. Now this is one to super important when our program downloads a web page. It gets back a big messy block of HTML code, all those tags like div, h3, p, and so on. Beautiful Soap will help us read talk that HTML and find exactly the data we want, kind of like a search tool for HTML. And this is Pandas, which we import as PD. Pandas is like Excel for Python. It helps us organize our collected data into a near table, call it a data frame. And it can also export the data to a CSV file with just one line of code. Very powerful. And finally, we import time. This one is simple but very important. We used it to add a small pause between each page request. Why? Because if we send too many requests too fast, the website server might think we are attacking it and block our program. So we be polite and while 1 second between requests is a good practice. Okay. Next, let's move to cell 2. We set up the variables we need before the main loop starts. That first variable is a base URL. Look at this. The first variable is base URL. Look at the http books.scrap.com page. See those curly braces there? That's a play placeholder every time our loop or runs. We replace that with the actual patch number. So patch one becomes patch HTML, patch two become patch two HTML, and so on all the way to patch 15. Really clean and simple. Next, result which start as an empty list, just two square brackets. This is our data container. And last, page num start at one. This is our page container. Every time we finish one page, we add one to this number. So this program knows to go to the next page. Simple, right? Next. Okay, now this is the most important part of the whole program, the main loop. This is where all the actual work happens. So I'm going to explain this carefully. We use this while true, which means keep doing this forever until I say stop. The loop will run again and again, going to the next page each time until one of our stop condition is triggered. Then we will using base URL. At the start of the each loop, we print which page we are currently reading. This membaca halaman page. So we can see the progress happening live in our output, very satisfying to watch. Then we build the URL using base URL format page num. This replace the with the current page number. So if page hum is 5, the URL become page 5 HTML. Then we use request get to actually visit that URL and download the page content. Next, we check this. Now, here's our first safety mechanism. We check if response status code 200. In HTTP communication, status code 200 means everything is okay. Here's your data. If we get anything else, like for 4.4, which mean page not found, it means the page doesn't exist anymore. So we print a message and break out of the loop. This prevents our program from crashing or running forever on a page that doesn't exist. Next, if we pass protection 1, we can use beautiful soap to parse the HTML content. We look for all article elements with the class product pod. That's how each book is represented in the HTML of this website. Next. Okay, so now we are inside the loop and we are convert the page as a data. Let's extract at we use for a loop to go talk each book one by one on the current page for each book. We extract for four places of information. First, title. First title, we get this from book H3. We use the title attribute here, not the visible text, because the visible title one, the page is sometimes outshort with the three dots. When it's too long, the full title is stored in the attribute, so we grab from here. We grab from there. Next, price. We find the paragraph tag with class price color and tag its text content. The strip at the end remove any extra space or new lines around the text. Clean data is important. Next, rating. This one is a bit interesting. The website doesn't store the rating as a number. Instead, it pulls the rating word CSS class, so we access class one, the second class value on the star rating paragraph, which give us words like one, two, three, four, or five. Next, availability. We check availability paragraph with class in stock availability and tag it text most books here and in stock. After extract all four files, we package them into a dictionary and append it to our result list along with the page number, and that's one looks done. The loop then moves us to the next book and the next until all 20 books on that page are processed. And at the end of each page, we print success message, add one to page num and call timestamp to wait 1 second before moving on. Then the whole thing repeats for the next page. So this is the output of looping. This the whole of book, 1,000, title, price, rating, availability, and page one. Next, we build data frame from scraping. Now let me show you the actual CSV file that was created. I'm going to open it right here in Jupyter. Look at this, a perfect clean table, all 1,000 books and lists here with their complete information. If you want, and if you scroll all the way to the bottom, you will see the total summary route we added. This file is now ready to be used for any further data analysis, whether that's using pandas, Apache Spark, or even uploading it to database. That's the power having clean structured data. And that's a wrap. In in this video, we have built a complete web scraping program from from scratch that automatically collect data from 50 pages of pagination and save it all into one CSV file. So thank you for watching my video. See you in the next video. Bye bye.